Hey everybody, I don't know why that keeps popping up. Anyway, hey, how's it going? So this video is to help you guys with the calculations for the copper sulfate lab. There was some preparation we had to do for that copper sulfate lab, so I just wanted to go through very quickly what those calculations were, okay? So we have these two different reactions, and basically we're trying to figure out which of these two reactions is the actual one that takes place, you know? And we start off with this imagined scenario of 13 grams of iron reacting, right? So the first thing we want to do is convert this 13 grams of iron to an amount of moles. And we're going to use dimensional analysis. Now, if we go to the periodic table and we look up the mass, the atomic mass of iron, we find that iron has this atomic mass of 55.85 grams. That also happens to be the molar mass. So we can say that 1 mole of iron is equal to its atomic mass in grams. So 1 mole, okay, has this mass. So again, dimensional analysis. 13 grams times which unit goes into the denominator. You can pause it here to think about it for a second. But if you remember correctly, grams is that unit. Okay. And then just copying the information from the conversion factor, 1 mole of iron was equal to 55.85 grams. Okay. And that essentially is the first step. And when we do our calculation, we end up getting 0.233 moles of iron. Okay, 0.233 moles of iron. That's what's going to be reacted. Now, here we go. 0.233 moles of iron is reacted. Now the idea is, well, with that much iron reacting, how much copper am I going to produce? Okay, according to this top equation up here, well, 1 iron atom would produce 1 copper atom. So it should make sense if I say that 0.233 moles of iron, okay, will equal that same amount of copper for the top reaction only, right? Because they're in this 1-to-1 ratio, okay, they're in this 1-to-1 ratio, so I know that whatever amount of iron I produce, okay, if I produce 1 iron atom, I should get 1 copper atom. Well, if I produce 0.233 moles of iron, that should be the same amount of moles of copper. Well, what would the number of moles of copper be if the reaction was not 1-to-1? Take a look here. The reaction is not 1-to-1, so we have to use dimensional analysis to figure out, okay, well, how much copper do I get with, again, this amount of iron? So once again, we're going to take the 0.233. Hold on one second. I'm going to try and save this here. Let me write it up here. 0.233. Okay. Moles of iron. I'm just going to put Fe here, right? Times. Now, Fe is going to go into the denominator here, and copper will go up top because, again, in dimensional analysis, I still want to put the canceled unit on the bottom, okay? And then I just take the numbers from the chemical reaction equation, okay? And that's going to give me an amount of 0.3495 moles of copper, okay? Now, let's convert these moles of copper to grams utilizing the ratio of, using the ratio of 63.5 Again, that's off the periodic table. So I'm going to take 0.233 moles of copper times, now this time, mole will go in the denominator, grams up top. It's 1 mole in the denominator, 63.55 grams. Okay, so let's see very quickly. That's going to give me 14.8 grams of copper. Okay, so with one reaction, I should get 14.8 grams of copper, but with this other reaction, where we produce 3,495 moles of copper, again, I'm going to set this up the same way, 63.55 grams over 1 mole. Okay, so now I do 0.3495 times 63.55. Now I get something that looks like 22.2 grams of copper. Okay, so again, at the end, we did 2 calculations because we don't know which reaction is true, but in one reaction, I should get 0.233 moles of copper, which is about 15 grams of copper. In the other reaction, I should be getting 0.3495 moles of copper, which is about 22 grams of copper. And the idea is we would perform the reaction to see which of these numbers do we get, and that's going to tell us which chemical equation was the correct one to start off with. All right. I hope that helped out. Certainly bring your questions to class.